This is the AB 5.3 review. Calculators are not allowed, and it is number 1. So on this one we are evaluating definite integrals exactly using techniques involving the antiderivative. So on all 3 of these, the way that the interior integrand is written is not anything that you will recognize from off of your derivative sheet. So what that means is you're going to have to manipulate what's in here in order to create a derivative that you recognize. So what I see here first is that I have 2 different setups. I have an x squared over an x, and I have a 1 over an x. Well, an x squared over an x is the same as an x, and a 1 over an x would be the derivative of the log. So once I split it up, I can see that I have the power rule to go backwards on, and I have the log rule to go backwards on. So that would give me an x squared over 2 plus a log natural of the absolute value of x evaluated from 1 to e. Now in order to evaluate, I plug my top number in first, so that would be an e squared over 2 plus a log natural of e, which is 1, and then I will subtract what comes out when I plug in a 1. Plug in a 1, I get a 1/2. Plug in a 1 here, and I get a 0. So if we finish this up, we'll end up with an e squared over 2 plus a 1/2, or we could get a common denominator and have an e squared plus 1 over 2. If we do the same process on part B, you can see again that we're going to split up the integral. So we'll have a 1 to 3, or the integrand I should say. The x cubed over an x to the 4th is a 1 over an x, and the x squared over x to the 4th is an x to the negative 2. I write these in different formats because I recognize that this one is going to be a log natural backwards, whereas this one will be a power rule backwards, and it's easier to work with power rules if we actually have the power written. So now I ask myself, what did I take the derivative of with respect to x that gave me 1 over x? The answer is log natural of the absolute value of x. And what did I take the derivative of with respect to x that gave me x to the negative 2? Well, I add 1 to that exponent and divide by the new power. Now rather than plugging in right now, I'm going to simplify, because some people have issues with this one when they try to start plugging numbers in. So instead what we'll do is we'll rewrite that as a negative 1 over x. So again, the first thing I plug in is that top number, which is a 3. So I'll have log natural of 3 minus a third. And then I need to subtract what comes out when I plug in the 1. Plug in the 1, I get a log natural of 1, which is 0, minus a 1 over 1. Combine my like terms, I'll have an ln of 3 plus a 2/3. Last one, part C, same process. I split this up. I'll have the integral from 1 to 2. A 3x to the 3rd over x to the 5th is going to be a power rule backwards, so I will write it as a 3x to the negative 2. And a negative x squared over x to the 5th will be a negative x to the negative 3, again a power rule backwards. If I now answer the question, what did I take the derivative of with respect to x that gave me this inside, I will move through the constant, add 1 to the power, divide by the new power, move through the constant, add 1 to the power, divide by the new power. And before I try to evaluate, I'm going to simplify. This is a negative 3 over x. This one is a positive 1 over 2x squared. Notice that the 2 did not move, it's still on the bottom, and the 3 did not move, it's still on the top, because the only thing raised to the powers were the x's. So this is now evaluated from 1 to 2. I plug in the 2 first, and then I subtract what comes out when I plug in the 1. Put that all together, we end up with 9/8.